Okay, guys, now that we kind of know how to work with these, how we know how to put them in, our nice standard form, let's go ahead and let's start doing some mathematical operations on them. So in the next section, we'll get into using these to solve equations. Right now, we're just going to get used to it, kind of like when you were back in elementary school and you got used to adding, subtracting, multiplying, dividing. We want to do that first so we're comfortable with these things, okay? In the next section, we'll worry about applying them to equations. Okay, so when we look at this, adding and subtracting complex numbers, here's the good news. This I right here, until the end of the problem, I'm going to treat the i's just like variables, just like if it was an x there, except for I'm using i's. Okay, so what I'll do here, what I got is I got 4 minus I. If this is a plus, I can just kind of get rid of the parentheses, just like how you did back in your algebra class. Okay, so I got 4 minus I plus 8 plus 5I. Well, I got a 4 and I got an 8. So I got a 12. Okay, and I got negative I plus 5I. That's 4I. All right. And look at that. That's in our nice form, our standard form for complex numbers. Pretty simple. Okay. Let's try this one. Now, I have negative 4 minus I. Now, I have a minus sign here, so I know I have to distribute this. So this is now minus 2 minus 3I, and we get minus 4 plus 5I. Okay, so this is working just like in algebra class, just like we're adding and subtracting polynomials, if you recall. Okay. So what happens next? Well, next I realize I have a negative 4, and I got a negative 2, which I know is negative 6. Minus 4 is negative 10. So I got negative 10. I took care of all the real parts. And then I have imaginary parts. Negative I and negative 3I is negative 4I, plus 5I is plus a single I. Negative 10 plus I. Not too bad. Okay. All right, adding and subtracting seems easy enough, so why don't we try multiplication? Now, when you look at this, hopefully when you look at this, you're thinking, oh yeah, multiplying polynomials. Usually the common way people do it is they think, oh, FOIL, in a case like this. And that's exactly what I'm going to do. And I'm going to treat the I just like it's a variable, just like it's an X. Until the end, then I'll adjust from there. So I'm looking at this, and I see my first, 1 times 2 is 2. My outer is negative 5I. My inner is 6I. And my last is negative 15. Now be careful here. I and an I is an I squared. Okay. Okay, where am I going from here? Well, I got 2. Now I can combine these because these are like terms, right? Negative 5I and 6I. So that's plus a single I. What about the I squared? Well, remember, I squared right here is negative 1. So that's what I'm going to do. I'm going to say, oh, well, that's minus 15 times negative 1. So this is really 2 plus I plus 15. Am I done? Well, no, I got some like terms, 2 and 15. So I end up with 17 plus I. So notice that this works just the same way as polynomials do. We just have to remember this little fact that I squared is negative 1 and convert it at the end. Okay, so what do I got going on right here? Well, let's see. In this case, I have negative 5I times 4 minus 3I quantity squared. So I think it would probably be best to go ahead and say, okay, well, let's expand that out. 4 minus 3I, 4 minus 3I, just like so. Okay. And I'll deal with this first. I mean, I could do this one first, but I think this will be easier. So this is going to be negative 5I times 16. I have minus 12I minus another 12I. That's minus 24I. Finally, I have negative 3I times negative 3I is a positive 9I squared. So I'm right there. Okay. Continue on right over here. I got negative 5I. Now notice I'm not distributing it yet because I want to deal with that I squared first. Okay. So I got 16 minus 24I plus 9 times negative 1. So that's really like minus 9. Okay. Negative 5i. Now, I got 16 minus 9. That's going to be 7. Okay. So I now have 7 minus 24i. So notice I like to simplify what I have in the parentheses first, so it'll be simpler. I don't have to distribute this as many times. From there, this will give me negative 35i, negative 5i times 7, plus, since we have a negative times a negative, let's see, 5 times 24, I believe that's 120, 120i squared. Well, there's that pesky I squared again, which we know is negative 1. So if I want to get it in a nice form right at the end, I know that that whole thing is going to be negative 120 for my real part. And I'm left with minus 35i for my imaginary part. Right there. Okay? So if you can multiply polynomials, you can multiply complex numbers. Just one little extra step. The last one I want to do is this one, and I notice I put a little star by it. And it probably looks pretty easy, okay? If we FOIL it out, we're going to get 4 minus 2i plus 2i minus I squared. That, of course, is going to be 4. The i's cancel, and that's going to be minus negative 1. In the end, this is just 5. So what I want you to notice here, what we call these are a pair of complex conjugates, we call them, okay? And the only difference really, and I'll give you a short little synopsis here, is the sign in between. These are complex conjugates. They're the same thing, just one's a plus bi, one's a minus bi. And why they're important is because this always happens with complex conjugates. You always get rid of imaginary parts. And sometimes we want that. For example, could we get this in the nice standard a plus bi form? What if I had an I in a denominator? Ooh, that might not work so well. Okay, something to think about. Okay, and we'll go over an example of that in the next video.